This is lesson 8.10, which is on systems of linear equations. So just a couple of warm-up problems. Number 1 says write an equation in slope-intercept form. We're given the slope is -4 and the y-intercept is 6. Well, slope-intercept form is y equals mx plus b. So all we have to do is plug in what we know. M is our slope, which is -4. So we have -4x, and then our y-intercept is that b, so plus 6. And that's all there is to it. Number 2 says write an equation in Poiseuille form to represent the table of values. So first thing I'm going to do is I'm going to find the slope. I'm going to choose these first 2 points. We have -6, 4, -3, 2. Then I'm going to plug that into my equation, y2 minus y1 over x2 minus x1. I'm going to take 2 minus 4, because those are my y values, over -3 minus -6. Well, 2 minus 4 is -2. -3 plus 6 is +3. So my slope is -2/3. And I'm going to plug that into my equation, point slope form, y minus y1 equals m times x minus x1. For the y1 and x1, we just pick any of these points. It doesn't matter. So I'll choose this third one, 3, -2. So y minus -2 equals, our slope is -2/3 times x minus, and then our x value is 3. The only thing I'm going to change about this is that minus the negative, so it should be y plus 2. And there's our equation in point slope form. Some vocab: system of linear equations consists of 2 or more linear equations with the same variables, which is also called a linear system. The solution of a linear system is an ordered pair that is a solution of each equation in the system. So on a graph, a solution to the system is everywhere the lines intersect. And that would be good to have written down. So to solve a system of linear equations by graphing. Step 1, you're going to graph the equation. Step 2, you're going to identify the intersection point. And step 3, you're going to verify that point is a solution of the system. So I'll show you how that's done. Example number 1 says solve the linear system. So we have 2 equations here. We have y equals -x plus 4. My slope for this one is -1 over 1. And my y-intercept is 4. So I'm just going to graph that out. So I'm going to start at 0, 4, because that's my y-intercept. And then my slope is just down 1 over 1. And I'm going to keep that going. And then I am going to go and connect these lines. And there we go. Then for 2x plus 1, my slope is 2, or 2 over 1. And my y-intercept is 1. So I am going to start with my y-intercept, which is 0, 1. And then my slope is up 2 over 1, up 2 over 1, up 2 over 1. So now that I have my 2 lines graphed out, my solution is the point where those lines meet. So I'm going to write that as an ordered pair. 1, 3. There's my solution. Then I'm just going to double check. So I'm going to plug those points into both equations and see if it works out. So we have 3, because that's our y, equals, and I'm going to put a little question mark here because we're not sure yet, -1, I'm plugging in -x plus 4. 3 equals, well, -1 plus 4 is 3, so that works. Then for the second one, we have 3 I'm just plugging in that point to my second equation. So 3 equals, put a little question mark, 2 times 1 plus 1. 3 equals, well, 2 times 1 is 2, plus 1 is 3. 3 equals 3. Boom, it works. There's our solution. So example number 2 says Katori and Mark each download songs. Mark downloaded 4 times as many songs as Katori. Mark also downloaded 6 more songs than Katori. Write a system of equations to represent this situation. So we have Mark and Katori. Let's say Mark is X. Katori is X and Mark is Y. So we know that Mark downloaded 4 times as many songs as Katori. So Mark is Y. So Mark has 4 times as many songs as Katori. So I'm going to write that as 4X. Then we also know Mark has downloaded 6 more songs than Katori. So Mark has, Katori is X plus 4. Then I am going to graph these out. So for my first one, my slope is 4 over 1, and since I don't have a y-intercept, it's just starting at 0, 0. So then it's up 4 over 1, up 4 over 1, and I'm going to connect those, and there's my line. Then for my second equation, my slope is just 1 over 1, because there's no number in front of x, so we know it's 1. And then our y-intercept is 4. So I'm going to go 0 up 4, and then 1 over 1, 1 over 1, 1 over 1. And then I'm going to connect those. So my solution is where these lines cross. So example number 2 says Katori and Mark each download songs. Mark downloaded 4 times as many songs as Katori. Mark also downloaded 6 more songs than Katori. We're going to write a system of equations to represent this. So I'm going to say Katori is X, Mark is Y. So we know that Mark has 4 times as many songs as Katori. So Mark has 4 times as many. We write that as 4X. And then we know that Mark also has 6 more songs than Katori. So I'm going to write that as X plus 6. So Katori songs plus 6 more is going to give me Mark's. Now I'm going to graph these equations. So y equals 4x. Since there's no y-intercept, that means we just start at the origin. Start at 0, 0. And then our slope is 4 over 1. So up 4 over 1, up 4 over 1. And I'm going to connect these points. And then for my second equation, y equals x plus 6. Well, my y-intercept is 0, 6. So I'm going to plot that. And then my slope is just up 1 over 1, up 1 over 1. Since there's no number in front of the x, that means really a 1 is there. So up 1 over 1, make that line. And then we can solve this. We can see where they intersect, and we write that as an ordered pair, so it looks like at 2, 8. Then just to double check that it works out, I'm going to plug them in for both equations and see if it checks out. So 8 equals 4 times 2. Well, 8 equals 8, so yep, that one works. And then we have 8 equals 2 plus 6. 8 equals 2 plus 6 is 8, so yep, that works. And then it says explain what the solution means. So the solution means, because I'm looking at x and y, x is Katori, y is Mark. So it means that Katori has 2 songs, and it means that Mark has 8 songs. Okay, example number 3, we're going to solve this. So my first line, negative 2x plus 1, so my y-intercept is 0, 1. And then my slope is negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to connect those. And then my next one is negative 2x plus 5. So that means my y-intercept is at 0, 5. And then we have negative 2 over 1 again. So down 2 over 1, down 2 over 1, down 2 over 1. And I am going to make that line. So these lines are parallel to each other. There's no intersection. So there's no solution. Okay, and then this next one, to graph these lines, I'm going to change both of these equations to be in slope-intercept form. So I want y to be by itself. So we have 2x minus y equals negative 3. I am going to subtract 2x from both sides, and I'm left with negative y equals negative 2x minus 3. But then I want y by itself, and right now really a negative 1's in front of it, so I'm going to divide everything by negative 1. And that leaves me with y equals 2x plus 3. Then I'm going to graph that out. So my y-intercept is 0, 3, and then up 2 over 1. And then we can also go down 2 to the left 1, because negative 2 over negative 1 is the same as 2 over 1, right? Because a negative and negative is positive. So down 2 over 1. So I'm going to connect those points. And then for my next one, we have negative 4x plus 2y equals 6. I'm going to add 4x to both sides. And I'm left with 2y equals 4x plus 6. Then I'm going to divide everything by 2, because I want y by itself. And I get y equals 2x plus 3. To graph that, my y-intercept is 0, 3. And then my slope is 2 over 1, so up 2 over 1, and I can also go down 2 to the left 1. Connect those points, and look, they overlap. It is the same line. So because of this, there are infinite solutions. So some good vocab and pictures to do in your notes. Intersecting lines, 1 solution. Parallel lines, no solution. And if it's the same line, so like our last example, there's infinitely many solutions.